So what is our today's goal? To learn RMF, rotating magnetic field. Let's talk about the rotating magnetic field and induction machine. The entire world, whatever we are observing, is designed with the help of electrical rotating machines only. Nowadays we cannot imagine our life without electrical machines. It will be started very simple, just to rotate something, and now we want to do everything with the help of electrical machine, because electrical energy is the most useful energy. It can be converted into any other energy form. Okay? Yes, sir. Induction machine founds a wide scope in present as well as in future also. Everything we want to replace by induction machines, especially with the three-phase induction machines, because of their self-starting nature and their ability to generate a high amount of torque. The first it was suggested by two scientists, because they are on the different places. So some says induction machine is designed by Galileo Ferraris, and some says it is designed by Nikola Tesla. So Ferraris developed his version in 1885 and Nikola developed his version in 1887. They are far away from each other, so I can't say that they know their research. Okay, but yes, we are going to understand the concept of rotating magnetic field in both the format that they have suggested. Okay, now please observe, this model is called as Ferrari's induction model, and this model is called as Tesla induction model. First they suggested for the two-phase and later on for the three-phase. Okay, yes sir. Three-phase induction motors has become an essential component of the motors in the modern industrial technologies and is used in a wide range of applications, including manufacturing, transportation, and power generation. The most cleanest active power can be generated by induction generator from wind turbine. So they are very important nowadays. Let's talk about rotating magnetic field first. How the field is rotating and what you are saying, sir, RMF. In order to understand RMF, first write down concept of rotating magnetic field. Write down first point. When three-phase stator winding displaced in space by 120 degree, is supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced. Which rotates in space at synchronous speed. And the direction of rotation depends upon phase sequence of supply. Direction of rotation depends upon phase sequence of supply. Is the sequence of supply. Is it okay? Now let us first discuss about the Galileo-Ferraris model. Okay. Now please observe. Suppose I have to construct a two-pole machine. So I have a iron piece, and this iron piece is you can assume like it is coming out of the board in a 3D form. Okay. I'm going to wound a wire over this iron piece. This is how I'm going to wound a wire. So this is a coil. This is how I'm connecting some windings over the core. Okay. Yes, sir. Hoping you all are aware with the grip or right hand curl rule. Yes, sir. Already in transformer itself, I have covered about the right hand curl rule. Okay. Now please observe here. This is your A and this is your A dash. Here I am representing A and A dash are connected. Similarly, we have B and B dash. Similarly, we have B and B dash. B and B dash are connected. Similarly, we have C and C dash. C and C dash are connected. Okay. Here I am going to short A dash, B dash, C dash with the external wire. A dash, B dash and C dash with the external wire. And now we have three different wires coming out of the machine as B phase, A phase and C phase. This is what we called a star, a connection, where the windings are being displaced in space by 120 degree. If you observe AA dash is one phase. Here I am representing AA dash. 120 degree apart from this. 120 degree electrically apart from this. I am considering a two-pole machine, so electrical and mechanical degrees are equal. Later on we will have a discussion over this. So 120 degree apart is your B phase and 120 degree apart is your C phase. Is it okay? Yes, sir. So A phase, B phase and C phase, three wires are coming out. We call this to be a star connected stator. Again I am repeating, this figure shows three-phase stator winding displaced in space by 120 degree. Displaced in space by 120 degree. Physically, the windings are being displaced by 120 degree. Okay? Yes, sir. And is supplied from a balanced three-phase current displaced in time by 120 degree. So next is your three-phase current which is displaced in time by 120 degree. Have you drawn up to this part? So let's have a discussion on three-phase current displaced in time by 120 degree. Up to this part everything is clear? You need to draw these two figures. If you found unable to draw, you can just leave that space. Later on you can draw. Three-phase stator displaced in space by 120 degree is supplied from a balanced three-phase current displaced in time by 120 degree. Then a rotating magnetic field is produced which rotates in space at synchronous speed, and the direction of rotation is the same as a phase sequence of supply. Okay, sir? Phase sequence of supply. Now please observe. Let me draw by myself so that it will be easy for you also. Sir, when a three-phase stator displaced in space by 120 degree is supplied by three-phase current is placed in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed. Yes, sir. When a three-phase stator displaced in space by 120 degree is supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed, which rotates in space at synchronous speed, which rotates in space at synchronous speed. Okay? Yes, sir. When a three-phase stator is placed in space by 120 degree, is supplied by three-phase current, is placed in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed. Is not possible. Okay. Please observe. When a three-phase stator is placed in space by 120 degree, is supplied by three-phase current, is placed in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed, which rotates in space at synchronous speed, and the direction of rotation is the same as phase sequence of supply, and the direction of rotation is the same as phase sequence of supply. Okay, sir. Let me show you again. These three are being shorted. So this is your three-phase stator is placed in space by 120 degree. And A, B, C, this will be your A dash are shorted, BB dash are shorted, and CC dash are shorted. Is it okay? When a three-phase stator is placed in space by 120 degree, is supplied by three-phase current, is placed in time by 120 degree. Already in a three-phase transformer introduction, I have shown you about the three-phase. Three-phase current means the currents have equal in magnitude and displaced in time by 120 degree. So, suppose the supply line coming is A phase, B phase, and C phase as a phase sequence. So I am representing 7 different instants of a three-phase current. A balanced three-phase current means at any instant, IA plus IB plus IC will be equals to 0. So here I am going to represent you 7 different instants. Okay, sir. Here I am going to show you 7 different instants. Okay, sir. So these are the 7 different instants. Okay, sir. Please observe. Current is IA, IB, and IC. Suppose the maximum current that is coming to the motor stator is 10 ampere. Then if 10 ampere current is allowed as per the thickness of the wire, let us suppose maximum current allowed will be 10 ampere. So this is your three-phase. This is your three-phase balanced current. I am representing a balanced three-phase current. A phase current. Yes, sir. This A phase current and then 120 degree apart is your B phase current. So this is your B phase current. This is your B phase current, and 120 degree apart is your C phase current. So I'm going to represent the C phase with a green one. So this is what we call A phase, B phase and C phase current, and the currents are being displaced in time by 120 degree. It means A phase current is maximum at time t omega t is equals to 0, and at time omega t is equals to 120 IB is maximum. Then 180, 240, 300 and 360. This is the entire 360 degree cycle. So if you observe in the 360 degree cycle, the three phase current displaced in time, IA plus IB plus IC, are displaced in time by 120 degree. It means first IA will be maximum, after 120 degree time IB will be maximum, and after 120 degree time IC will be maximum. Is it okay? Yes, sir. So we have balanced three phase current. What is the criteria of a balanced current, sir? Balanced current means at any instant if you observe, IA plus IB plus IC is equals to 0. So three phase balanced current means at any instant, three phase balance current means IA plus IB plus IC is equals to 0 at any instant. And you know that. Yes, sir, 1 plus omega square is equals to 0. We know that, sir. Great. So three phase balance current IA plus IB plus IC is equals to 0 at any instant. This is a balanced three phase current. Now this balanced three phase current is being supplied to the balanced three phase stator. The windings are being physically displaced by 120 degree. Balanced three phase currents are being displaced in time by 120 degree. Yes, sir. So the current will come in this fashion, like IA, then IB, then IC. Is it okay? Yes, sir. Let us suppose a positive current means a current coming into the phase. So negative current means current going away from the phase. Positive current means current coming into the phase. So negative current means current going away from the phase. Yes, sir. So now please observe here. Sir, we all know that when a current flows through a coil, it will create a MMF. MMF upon reluctance can be represented by a flux. So sir, if the current flows through a wire, if a current flows through a coil, it will create a MMF. Yes, sir. By the right hand curl rule, we know that if a current flows through a coil in the direction of right hand curl, then right hand thumb is the direction of magnetic field. Yes, sir. Now please observe here. At instant 1, if I am interested to understand instant 1, so at instant 1, what is the magnitude of the current flowing in A phase? 10 ampere, and that is positive 10 ampere. So I am considering 10 ampere is coming into the A phase. So this current is going to take a path in this way. Yes, sir. So this 10 ampere current will take path in this way. Yes, sir. Now all the phases are identical. A phase, B phase and C phase. All the phase windings are identical. But the windings are physically being displaced by 120 degree. Okay, sir. So all the windings are identical, and if the current will come up to this point. Now from this, the two equal impedance path will be opted. So the current is going to divide it into equal portion as per the KCL. Yes, sir. So current is going to be divided as 5 ampere and 5 ampere. Now this current 5 ampere is going to complete its path in this manner. Is it okay? Yes, sir. So it means 5 ampere current is coming out of C phase. So one can indicate IC is equals to minus 5 ampere. Already it is minus 5 ampere, sir. From the supply itself, sir. From the supply itself, sir. Now come to the second path. This 5 ampere is going to complete its path through the windings in this fashion. Yes, sir. Now 5 ampere current is coming out of B phase. This indicates minus 5 ampere current is going into B phase. So IB will be minus 5 ampere. Sir, it is minus 5 ampere, that is in supply itself. This is the greatest advantage of 3-phase system also. Because in a 3-phase system, we only need 3 wires to give path to the current to flow. But there is a condition, current must be balanced. And what is the meaning of balanced current? Sir, IA plus IB plus IC is equals to 0 at any instant. I have represented 7 different instants to you. And all the 7 instants, if you observe, you found IA plus IB plus IC is equals to 0. Is it okay? Yes, sir. Now please observe. As per the direction of current flowing into a coil, it will create a magnetic field. And sir, magnetic field upon reluctance is your flux. Now please observe. Sir, all the phases will have identical number of turns. So that phase will give maximum MMF whose current is maximum. At this particular time, IA is 10 ampere. However, IB and IC both are minus 5 and minus 5 ampere. So it means maximum portion of the flux will be contributed by A phase. And what is the direction? Sir, as per the right hand curl rule, if the current is flowing in the direction of right hand curl, then thumb is the direction of magnetic field. If the current is flowing in the direction of right hand curl, then thumb is the direction of magnetic field. This indicates magnetic line of forces are coming out from this port. So this is going to act as a north, sir. That portion is said to be north, from where magnetic line of forces are coming out. And that is said to be south, from where magnetic line of forces are again going back to the material. So it means, sir, magnetic line of forces are going to complete their path because of equal magnetic potential. They are going to complete their path in this manner. Yes, sir. So this is how one north and south we are able to see. Is it okay? Yes, sir. Now observe how much current is flowing in this B phase. Sir, current is flowing in the direction of right hand curl. The current is flowing in a coil in the direction of right hand curl. So thumb represents the direction of magnetic field. This indicates the magnetic line of forces are coming out from this port. It will act as a north. And if you observe here, the current is going in a right hand curl in the direction as indicated by the right hand curl. So right hand thumb is representing the direction of magnetic field. Definitely, sir, the magnetic line of forces are returning back to the material. So this is going to act as a south, because they have equal number of turns, as well as they are carrying 5 ampere. It means equal ampere also. So the magnetic potential north and south are equal. Magnetic line of forces always try to flow through the low reluctance path. So magnetic line of forces are going to complete their path in this fashion. Is it okay? Yes, sir. This is how magnetic line of forces are going to complete their path. Similarly, sir, if you observe here, what is the direction of current? As per the right hand curl rule, current is flowing in the direction of right hand curl. Thumb is the direction of magnetic line of forces. Current is flowing in the direction of right hand curl. So thumb is the direction of magnetic field. So from here, magnetic line of forces are coming out of the material. This will become north. Here material, it is going back to the material south. Magnetic line of forces are completing their path in this manner. So can we represent all the magnetic line of forces with a single this way? Yes, sir. Now basically this is a two-pole machine. It's a two-pole machine. It's a two-pole machine. Above this portion all is south and below this portion all is north. So as per the current flowing at instant 1, the position of the magnetic field is here. Now let's come to the instant 2. You need not, if you want you can draw, otherwise you can just draw up to 3-phase instant and this portion. Later on just I am going to show you how the field is changing. We all know, sir, if the current flows in the direction of right hand curl, then thumb is representing the direction of magnetic field. that portion of the material is said to be north, from where magnetic line of forces are coming out of the material, and that portion is said to be south, from where magnetic line of forces are coming back to the material. Now please observe. Please give me 5 minutes. After that you can draw. Please observe. Now please observe. Now please observe. Sir, instant 1 we have observed. Let's talk about instant 2. Let's talk about instant 2. Sir, we have observed instant 1. Let's talk about instant 2. Okay, sir. We have observed instant 1, sir. At instant 1, we have observed all the fluxes are towards the A phase. All the fluxes are towards A phase, sir. Yes, sir, I am able to see that all the fluxes are towards A phase. Now please observe. Now please observe. We have A phase, we have B phase, we have C phase. So C phase is with a, let me change the color to green. Now A phase, B phase and C phase are being shorted with a common wire, that is A dash, B dash, C dash. If we are interested to make a star connection, and we have A phase, B phase, C phase as coming out. A phase, B phase and C phase coming out. Is it okay? So I'm not going to change anything. Yes, sir. Now please observe. We have A phase, B phase and a C phase. We have A phase, B phase and a C phase. Please observe. I'm interested to observe the different situations. Now please observe. I'm interested to observe the different situation. Now please observe. We have observed instant 1. At instant 1, all the fluxes are directed in this way. This entire portion is acting as a south, and this lower half will be acting as a north, sir. Yes, sir. Now come to the instant 2. This is a supply. This is coming from the supply itself. We have a generator. That generator is 3 phase, and the 3 wires which is going outside of our houses, 3 phases, that 3 phases are carrying current in this way. Okay. So when I am going to connect my machine with these 3 phases, then all for a balanced load, they are going to take equal amount of current, and that current I have represented here, A phase, B phase and C phase, displaced in time by 120 degree. Now observe instant 2. Please observe instant 2. Which current is going to be maximum? Sir, C phase current is going to be maximum, and that will be negative maximum, sir. We have considered positive maximum current coming into the phase, so negative maximum current is going out of the phase, sir. It means you can represent here, sir, C phase current going out of the phase, sir. You can represent, sir, C phase current going out of the phase, sir. Here you can represent IC, and that IC is equals to minus 10 ampere. IC is going inward, so minus 10 ampere means 10 ampere is coming outward. So this 10 ampere must come in this way. This 10 ampere must come in this way. Yes, sir. If this is 10 ampere and there will be an electrical connection, then that electrical connection must satisfy, that electrical connection must satisfy KVL, also KCL. Yes, sir. The electrical connection must satisfy KCL, and for satisfying KCL, this must be equals to, sir, 5 ampere, and this must be 5 ampere. Now, if this is 5 ampere, then 5 ampere is coming in this fashion. Please try to observe. 5 ampere is coming into the A phase. So, IA will be 5 ampere, and 5 ampere is coming into the B phase also. Please observe. We have to show this B phase current. Coming out, I have represented wrongly. Coming out means it is going in this way. Yes, sir. So B phase current IB is also 5 ampere. The supply itself representing when C phase current is negative 10 ampere, at that particular time A phase current and B phase current are plus 5 ampere. So it is supply itself. Yes, sir. Now the current flowing in the windings in this fashion, as per the right hand curl rule. Please observe. Let me make it bigger. So please observe. As per the right hand curl rule, the current is maximum in C phase. So maximum flux will also be contributed by C phase. Now 10 ampere current is going in this fashion. As per the right hand curl rule, flux is coming out. As per the right hand curl rule, flux is going in. So C phase, because of the C phase 10 ampere current, magnetic north and south polarity can be represented here, and the magnetic line of forces are going to complete their path in this manner. Is it okay? Yes, sir. In this manner. This is going to act as a north, sir, and this is going to act as a south, sir. Now 5 ampere current is in this, and 5 ampere current is in this, equal number of turns. So equal magnetic potential. As per the right hand curl rule, magnetic line of forces are going to take a minimum reluctance path. So they are going to opt this path because they have an equal magnetic potential in this way. Similarly, if you observe here, so flux is coming out, flux is going in. As per the concept of minimum reluctance path, you can represent for an equal magnetic potential. Magnetic line of forces are completing their path in this way. So where is the flux at this instant? If you observe, you can observe the entire flux to be tilted from position 1 to this position at instant 2. So at instant 1, we have observed the flux position, sir. And now at instant 2, we have observed the flux position, sir. Are you able to see this? Yes, sir. Previously, the flux is here. Sir, at instant 2, the fluxes are directed opposite to C phase. Because C phase current is negative maximum, so the fluxes are directed opposite to C phase. Previously, the fluxes are directed towards the A phase. A phase current is maximum. Now the fluxes are directed opposite to C phase. Is it okay? Yes, sir. So, sir, instant 2, we are able to understand instant 2. Now please observe instant 3. Once again, please observe instant 3. At instant 3, which current is maximum? Please observe. At instant 3, sir, IB is maximum. IB is positive maximum, and at the same time, IA and IC are negative half of the maximum, means 5 ampere and 5 ampere negative. We have considered positive current to be coming into the phase. Yes, sir. So 10 ampere current is coming into the B phase. Okay, sir. So positive ampere current means 10 ampere is coming into the phase, sir. So this current will going to take its path in this way. Now it will have a 2 equal path. So current is going to divide it into 2 equal impedance path equally. And now this current completes 5 ampere outward. It means what is IA? IA will be equals to minus of 5 ampere. If you have represented 5 ampere coming out of A phase, it means minus of 5 ampere is coming into the A phase. Yes, sir. Similarly, this 5 ampere is going to complete its path. Let me show you with a different color. This 5 ampere is going to complete its path in this way. Please observe, the current is coming in this way. So 5 ampere current is coming out. It means what is IC? Minus of 5 ampere is going in. Is it okay? Yes, sir. Which phase having maximum current? B phase. So which phase contribute maximum flux? B phase, sir. Now what is the direction, sir? As per the right hand curl rule, if the direction of current is in the direction of right hand curl, then thumb is representing the direction of field, and that portion is said to be north from where magnetic line of forces are coming out of the phase, and that portion is said to be south from where magnetic line of forces are going into the phase. So this indicates, sir, this portion will going to act as a north. Yes, sir. And the opposite one is going to act as a south. So this will become north and this will become south. Please observe. Yes, sir. Similarly, if you observe, this is for 5 ampere and this is also created as a south for 5 ampere. So this will be your north and this will be your south. Magnetic line of forces always try to flow through the minimum reluctance. For the equipotential, the magnetic line of forces are going to complete their path in this way. Similarly, if you observe here, this will be your right hand curl. So thumb is coming out, and this will be your right hand curl. Thumb is going in the material. So magnetic line of forces are going to complete their path in this manner. Please let me know, are you able to see that all the magnetic line of forces are now directed towards B phase, as B phase is positive maximum. So all the magnetic line of forces are directed towards B phase. When a three-phase stator, now my wordings, when a three-phase stator displaced in space by 120 degree is supplied from a three-phase balanced current displaced in time by 120 degree, then a rotating magnetic field is produced. Now you are observing there will be a change in the position of the magnetic field. Let us observe one more. Let's observe one more. Hoping you are able to understand up to this part. Let's observe. Now please see. Instant 4 and instant 5. Please tell me which current is maximum at instant 4. Which current is maximum at instant 4? Which current is maximum at instant 4? Sir, A phase current is maximum at instant 4, but it's negative maximum, sir. A phase current is maximum at instant 4, but it is negative maximum, sir. And negative maximum means, sir, 10 ampere is coming out. Negative maximum means 10 ampere is coming out. Minus 10 ampere is going in. It means 10 ampere is coming out. So you can represent 10 ampere in this fashion, sir. If this is 10 ampere, sir, so these must be 5 ampere and 5 ampere, because electrical connection, so KCL must satisfy. So if this will be 5 ampere, it means, sir, this 5 ampere is coming in this way. Yes, sir. So we have a 5 ampere coming from C phase. So IC is positive 5 ampere. And 5 ampere we have coming from B phase also, sir. 5 ampere we have coming from B phase also, sir. Yes, sir. Which current, which phase will contribute maximum flux? A phase, sir, because MMF is N into I. So number of turns are same. So the phase carries more current will create more MMF. Sir, A phase is going to create more MMF. But what is the direction? Sir, what is the direction? As per the right hand curl rule, if the current flows in the direction of right hand curl, then thumb represent the direction of magnetic field. It indicates, sir, magnetic line of forces are going to complete their path in this manner. magnetic line of forces are going to complete their path in this manner. Please tell me, are you able to understand? Yes, sir. So this is going to be north and this is going to be south. Now please observe, this will be south, sir, and this will be north, sir. So we have north and south. Magnetic line of forces are completing their path in this manner. This is north, sir. North, sir. This is south, sir. Having equimagnetic potential. So this is how magnetic line of forces are going to complete their path. This machine is still of two-pole machine only, but the position of the flux is now being reversed from the initial position. Yes, sir. So we are able to observe the change in position of the field, sir. We are able to see the change in position of the field, sir. So now you can easily draw the instant 5. Which current is maximum at instant 5? Which current is maximum at instant 5? At instant 5, which current is maximum? IC is positive maximum. Now IC is positive maximum. IC is positive maximum means 10 ampere current is coming from C phase. IC is positive maximum means IC is equals to plus 10 ampere. So 10 ampere is coming into the phase. So if 10 ampere current is coming into the phase, then you can represent this 10 ampere to be here, and it will be divided as 5 ampere and 5 ampere. Now this 5 ampere is going to be out from A phase. That indicate IC is equals to minus 5 ampere is coming in if 5 ampere is going out. Similarly, this 5 ampere will take a path in this way. 5 ampere is coming out from B phase. So IB is minus 5 ampere. Great, sir. So that is the importance of three phase. That is the importance of three phase. If the three phase is balanced, then three phase itself becomes creating a path from the other two phases. Which phase will create maximum MMF? C phase, sir. Now if you observe, this will become north and this will become south. Magnetic line of forces are going to complete their path in this manner. Yes, sir. So this is how magnetic line of forces are going to complete their path because of equimagnetic potential. This is your north, this is your south. North, south. But this north-south will have different magnetic potential comparative to this. Yes, sir. Now, this is how they are going to complete their path. So it can be clearly observed, sir, if we are going to draw all the 7 instants, it can be clearly observed, sir, the flux is rotating. The flux is rotating. Is it okay? Yes, sir. And we are also able to observe the magnitude of the flux is same. The magnitude of the flux is same. Because at instant 1, at instant 2, at instant 3, everywhere we found that one phase carrying 10 ampere and other two phases are carrying 5 ampere and 5 ampere. And the position difference is same. It means the magnitude of the flux is same. So we found when a three-phase stator displaced in space by 120 degrees supplied from balanced three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced. Then a rotating magnetic field is produced. Sir, then a constant magnitude rotating magnetic field is produced. Yes, that will be more better. Then a constant magnitude rotating magnetic field is produced. Is it okay? Is it okay? Yes, sir. Up to this part, everything is clear? Great, sir. Similarly, you can draw for instant 6 and instant 7 also. Similarly, you can draw for instant 6 and instant 7 also. Is it okay? Yes, sir. At instant 6, what happened? Which current will be maximum? If you observe at instant 6, which current will be maximum? At instant 6, we found, sir, which current will be maximum? Sir, B phase negative maximum. So, the flux will be directed opposite to B phase. And at instant 7, A phase is maximum, sir. Please observe, please observe, please observe. Are you able to see this? Are you able to see this, sir? we are able to observe, that fluxes are rotating. The flux is rotating. And the flux is rotating, and the speed of rotation depends upon, please observe. Now, I have represented you entire 5 different instant. So you know about all the instant. Again, I am going to show you. Please observe. Suppose we have a flux here. I am representing the flux. Please observe. I am representing the flux here. So suppose we have flux here. Yes, sir. The arrow tip is directed here at instant 1. At instant 1, which current is maximum? A phase current is maximum, sir. So A phase, it will be directed towards A phase. At instant 2, C phase, negative maximum, sir. So opposite to C phase. At instant 3, B phase, positive maximum. So towards B phase. At instant 4, A phase, negative maximum. So towards opposite to A phase. At instant 5, C phase maximum, sir. So towards C phase. At instant 6, B phase negative maximum. So opposite to B phase. At instant 7, same as instant 1, sir, A phase maximum. Are you able to observe that this flux is moving? Please tell me. And if the frequency of supply is increased, then if the frequency of supply is increased, the change from A phase to B phase is faster, and B phase to C phase is faster. So if the change is faster, the speed is increasing. Are you able to see this? Yes, sir. Means I can say, sir, if the supply frequency is higher, then the speed of rotation will be faster, because the current flowing in the different winding sections are changing their position. Sir, this is different in time. The currents are displaced in time. Sir, the currents are displaced in time means, let us suppose the time period as 20 millisecond. 20 millisecond means 1 upon 50 hertz. Okay. Yes, sir. Suppose we have a frequency of 50 hertz. So that indicates what is the time period? Sir, time period is 20 millisecond. For 20 millisecond, what is this value, sir? This value is omega t. Sir. Omega t is equals to 60, sir. Omega t is equals to 60 can be represented as pi by 6, sir. Pi by 6, sir. Pi by 6 or pi by 3? Pi by 3, sir. Pi by 3, sir. So omega is 2 pi by capital T into small t is equals to pi by 3, sir. So this pi and pi will cancel out. Small t will become capital T by 6. Now capital T is a 20. So 20 by 6 is 3.33 millisecond. So it means the position of flux changed from omega t is equals to 0 seconds to after 3.33 second is this one. Sir, the position of change in flux is, sir, the position of change in flux is, at omega t is equals to 0, the flux is here. And after 3.33 millisecond, the flux is here. After 6.67 millisecond, it means after 120 degree in time, the flux is here. So the position of the flux is dependent upon the frequency of current flowing into the winding. Very important part. Are you able to understand this? Can you feel this? Are you able to feel this? Please tell me. So on what factor does the speed of rotating magnetic field depends? Sir, it depends upon the frequency of current. It depends upon the frequency of current flowing into the winding. What is the direction of rotation? Sir, it is rotated from A phase to B phase to C phase. Okay, okay. Let us change any two supply terminal. Let us change any two supply terminal. So, if I am going to change any two supply terminal, then what happened? Sir, if you are going to change any two supply terminal, please observe, please observe. Let me copy this. If I am going to change any two supply terminal, then what happened? If I am going to change any two supply terminal, then what happened? Add to resources FE35. Okay. Now please observe. Now please observe. It is from the resources FE35. FE. FE35. Okay. Now please observe. Now please observe. I am going to change. Please observe. Please observe. I am going to change the phase sequence of supply. How to change the phase sequence of supply? We have three terminals coming out from the machine A, B, C, and we have three supply line A, B, C. I am going to interchange any two supply line. So if I am going to connect the B of the machine with the C of the supply line and C of the machine with the B of the supply line, then current entering into the machine are going to be changed. Okay, yes sir, the current flowing into the windings are going to be changed by changing any two supply terminals. So by changing any two supply terminals, what happened? Sir, the phase sequence of supply is changed. Now I am going to show you phase sequence of supply. Please observe. When phase sequence, supply phase sequence, when supply phase sequence is changed, when supply phase sequence is changed. Now please observe. I am changing the supply phase sequence. I am changing the supply phase sequence. Please observe. Please observe. When supply phase sequence is changed. So I am going to change the supply phase sequence. When supply phase sequence is changed. When supply phase sequence is changed. Please observe. I am going to change the supply phase sequence. Now, if this will be your IA, IC, IB. What is the phase sequence of supply? ACB now. At instant 1, we get the same thing. At instant 1, we get the same thing. Please observe. Yes, sir. The flux will be directed towards A phase as A phase is maximum. What is at instant 2? Which current is maximum? Now B phase current is maximum. A negative maximum. So the flux is going opposite to the B phase? Yes, sir. So where is the flux? Sir, opposite to the B phase. It means it will be here. At instant 1, A phase maximum towards A phase. At instant 2, B phase negative maximum. At instant 3, C phase positive maximum. At instant 4, please observe, please observe. I want that you need to feel this. Please observe. At instant 4, at instant 4, at instant 4. Sir, A phase negative maximum. At instant 5, B phase positive maximum. At instant 6, sir, C phase negative maximum. At instant 7, A phase positive maximum. What is the direction of the flux? What is the direction of the flux? The direction of the flux is reversed. So you can say, sir, when a three-phase stator displaced in space by 120 degree is supplied by three-phase current displaced in time by 120 degree, then a constant magnitude rotating magnetic field is produced, which rotates in the direction, as per the phase sequence of supply, or you can say which rotates in the direction as per the phase sequence of supply. Are you able to understand this? Now now do you have an entire feeling of this rotating magnetic field? When phase sequence is changed, I know you are unable to note down all these things, but since you can download, I know you have noted up to this part only, but since you can download the notes, so notes are in the similar form. Please observe, this is your page 1, already you have this noted. Okay, then on the second, I have created this one and show you about the field at instant 1, then instant 2 and instant 3 is there, then instant 4 and instant 5 is there, then when phase sequence is changed, again instant 1 is here, and then instant 2 is here. So hoping now you are able to recall all these things. You need not to draw such a heavy diagrams, just you need to have a great feeling related to the rotating magnetic field. Later on, the diagram which I am going to draw now, that you can draw. Okay, presently up to this part, please let me know whether you have a perfect feeling related to the rotating magnetic field. Great. So, sir, today I have feel how the field is rotating and what are the factors on which rotating magnetic field depends. Sir, when a three-phase stator displaced in space by 120 degree is supplied from three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed, which depends upon the supply frequency or frequency of current flowing into the winding, and the direction of rotation is the same as phase sequence of supply. Is it okay? Please tell me up to this part. Let's have a concept of rotating magnetic field for a Tesla model. This model is not perfect. Why? Because this model will have a different air gap and different air gap. This is what we call salient pole stator. We never use a salient pole stator for our induction machine, and there is a reason behind that, because in a salient pole stator the air gap is different, and because of different air gap it is highly affected by the harmonics. Later on we see what is the harmonics in the rotating machines. So it is highly affected by the harmonics, which decreases the performance of the machine to many extent. Whenever we have to use a three-phase induction machine, we always prefer to design a cylindrical stator three-phase machine. So now I am moving towards the Tesla model. Okay, now please observe, I am going to move towards the Tesla model. Up to this part everything is clear. Now you have a feeling related to the rotating magnetic field. Now you have a feeling? Yes, sir. Let's come to the Tesla model. Simple model, sir. Let's come to the simple cylindrical model, sir. What is the concept of rotating magnetic field in a round rotor? For induction machine, round stator construction is preferred over salient type to reduce harmonics. So already I have told you about this. This is round rotor stator. Okay. Now please observe. When a balanced three-phase stator displaced in space by 120 degree is supplied from a balanced three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced. Again, I am going to repeat. Please observe. So we have a balanced, please, you need to draw this. We have a balanced three-phase current. Okay. When I am saying balanced three-phase current, it means IA plus IB plus IC at any instant equals to 0. Let us suppose the thickness of windings such that maximum current allowed is 10 ampere. So 10 ampere, 5 ampere, 0 ampere, minus 5 ampere and minus 10 ampere. And here I am representing A phase, B phase and C phase. This is your 0 degree instant, 60 degree instant, 120 degree instant, 180 degree instant, 240 degree instant, 300 degree instant and 360 degree instant. This is depends upon the frequency of supply, and if the frequency of supply is 50 hertz, then time period is equals to 20 milliseconds. Okay, yes sir. Now please observe, we have A phase, B phase and C phase displaced in time by 120 degree. This is 3-phase supply displaced in time by 120 degree. 3-phase supply displaced in time by 120 degree. Here I am going to represent you about the 3-phase stator. Let me show you in a more better way. Now you need to note that, please. So we have A phase. This is, you can imagine that a cylindrical structure is coming out, and this cylindrical structure will have a slots in which I am going to place a conductors in a coil format. Okay, yes sir. And this coil, one side is A, another side is A dash. Similarly, other one is 120 degree displaced from this, that is BB dash. They are physically displaced in space. They are physically displaced. When I am saying displaced in space, it means physically displaced. Okay. Now 120 degree displaced is your C phase, C dash. Same A dash, BB dash and CC dash. A dash, B dash, C dash are shorted, and A, B, C are coming out of the body. Okay. So we have A, B and C are coming out, while A dash, B dash, C dash are being shorted. So A dash, B dash and C dash are being shorted. Okay. A dash, B dash, C dash are being shorted, and the windings coming out is A, B, C. The purpose of representing such a in an artistic manner is to make you assume like the wire is outside. Okay, this is your entire body and the wire is joint outside. Okay, yes sir. Now we have A, B and C, and we have A dash, B dash, C dash joint. So this will be your 3-phase stator connected in star. Is it okay? I am removing this, otherwise it may create big mistake. In this mode, I should avoid rubber. No issue. A dash, B dash, C dash. A dash, B dash, C dash are shorted, and A, B, C are the wires coming out. Okay. Yes sir. Now please observe how the field is going to rotate. We all are aware with the term right hand curl rule. Right hand curl rule says if the current in a conductor flows in the direction of right hand thumb, then right hand curl is representing the direction of magnetic field. Yes, sir. If a current flows in a coil in the direction of right hand curl, then thumb is representing the direction of magnetic field. And in case if the current flows in the direction of right hand thumb in a conductor, then right hand curl is representing the direction of magnetic field. Yes, sir. Now please observe here. Now please observe here. I'm going to use it. Please observe here. Now please observe here. So we have A phase, B phase and C phase. We have A phase, B phase and C phase. Please observe here. A phase 120 degree apart is your B phase and 120 degree apart is your C phase. Okay. A phase, B phase and we have C phase. So this will be your C phase. Okay. Yes, sir. I'm giving the name also. So this will be your A dash, B dash, C dash. Please observe. Please observe. Please observe. At instant 1, which phase current is maximum at instant 1? Which phase current is maximum at instant 1? Yes, sir. Which phase current is maximum at instant 1? Sir, A phase current is maximum at instant 1. So, at instant 1, current in A phase is maximum. Assume that we are observing from this side and the current having maximum, the current which will have a maximum current is observing like the current is going away. Okay. Let us assume we can take it coming towards or away. So A phase current is maximum. So let us take A phase current is maximum. Let us take A phase IA in this way. Okay. Yes, sir. Sir, can we take it opposite? Yes, you can. But whatever you are going to take, you need to keep the symmetry for all. Okay. Now please observe. Let us suppose the current. Let us suppose I am observing from this side and the 3 wires are out. The 3 wires are out from the last portion. Okay. Yes, sir. Now please observe. So 10 ampere current is going away. You may also consider, like, if you want, you can consider the previous one only. Suppose I am observing from this side. The wires are there. So A phase 10 ampere current, IA is coming. At the same time, what about B phase and C phase? B phase and C phase currents are minus 5 ampere and minus 5 ampere. So minus 5 ampere means 5 ampere is coming out. Minus 5 ampere means 5 ampere is coming out. Is it okay? Yes, sir. IC is minus 5 ampere and IB is also minus 5 ampere. Can I represent in this way? Yes, sir. Now please observe. If I am observing from the back side of the machine and the current is coming into the machine, then current is coming towards the observer. Can I say the current is coming towards the observer? The current which is coming towards the observer is marked as dot, and the current which is going away from the observer can be marked as cross. Is it okay? Yes, sir. Now please observe. This is 10 ampere current. So I have represented a bigger dot and a bigger cross. Now if 10 ampere current is coming here, and now at A, B dash and C dash are connected. So current is going to be 5 ampere and 5 ampere. Current is going to be 5 ampere and 5 ampere in C dash and B dash. And in C and B, currents are 5 ampere and 5 ampere. Since I have represented dot as a plus 10 ampere, so for a minus 5 ampere, I need to represent a current by cross. We can observe it. Actually, you are saying this is A and A dash. Okay, this is A and A dash. You have observation from this side. So if the current 10 ampere is coming here, so it is outward, means towards the observer, and dot means current is going away from the observer. Is it okay? Yes, sir. Now when A dash current will be reaches here, then this current is connected with these two. Yes, sir. So from C dash and B dash, we found the current is coming towards the observer, and from B and C, again we are found that current is going away from the observer. Is it okay? Yes, sir. Now, hoping you are able to understand up to this part. Which current is maximum? A phase current is maximum. So which phase current is maximum? A phase current is maximum. So maximum flux will be contributed by A phase only. Presently, we all know that if a conductor carries current, it will create a magnetic field. What is the magnetic field this create? Sir, it will create a magnetic field in this way. They also create a magnetic field in this way. Yes, sir. But which current is maximum? A phase current is maximum. So maximum flux will be contributed by A phase. Maximum field will be created by A phase. Yes, sir. So this A phase is going to create a field in this fashion. A phase is going to create a field in this fashion. As per the right hand curl rule, if this will be the direction of current, thumb is the direction of current, then right hand curl is the direction of magnetic field. So the direction of magnetic field created will be, because of the current flowing in A phase, the direction of magnetic field created will be in this fashion. Please tell me, are you able to understand this? Yes, sir. Now please observe. I'm going to show you. All these three will create a magnetic field. If I'm going to represent a single line to show the magnetic field created by these three conductors, then the magnetic field created by these three conductors can be represented by this dotted line. Again observe, maximum current is in A phase. Current is in the direction of right hand thumb. Then right hand curl is the direction of magnetic field. So if the current is in the direction of right hand thumb, right hand curl is the direction of magnetic field. So the current flowing in these three conductors are going to create a magnetic field in this way. Is it okay? Yes, sir. So which terminal acts as a north and which terminal will act as a south? Sir, at this particular instant, the magnetic line of forces are coming out from this terminal. So this will be going to act as a north and this will be acting as a south. Again, it's a two-pole machine only with this as a north and this as a south. Magnetic line of forces are completing their path in this manner. We can represent the magnetic line of forces with this arrow. Is it okay? Is it okay? Yes, sir. Maximum current is in A phase. So maximum flux will also be contributed by A phase. But at the same time, current in B phase and C phase are half of the maximum. So we have the flux to be directed in this way. Now come to the instant 2. Which current is maximum at instant 2? Please tell me which current is maximum at instant 2. Now only I am observing the phase which will having maximum current. So which phase will have maximum current at instant 2? Which phase will have maximum current at instant 2? At instant 2, this is your instant 1, instant 2, instant 3, instant 4, instant 5, instant 6, instant 7. Which current is maximum at instant 2? Please tell me. Sir, at instant 2, C phase current is negative maximum. Negative maximum means we have created A phase current coming inside, so outward. 10 ampere. Outward means cross. This is dot. So maximum flux will be contributed by, sir, C phase. As per the right hand curl rule, if the current is flowing in the direction of right hand thumb, then right hand curl is representing the direction of magnetic field. What is the direction of magnetic field now? Sir, the direction of magnetic field can be represented in this way. Please observe, the direction of magnetic field can be represented by this way. Is it okay? Yes, sir. What is the position of north and south? On stator body, north and south position get changed. North and south position onto the stator body gets changed. Is it okay? Is it okay? Now let's have a discussion over the other instants also. Okay, let's have a discussion over the other instants also. So what about instant 1, 2 we have completed. Let's observe instant 3. So which phase current is maximum at instant 3? Sir, we have A dash, B dash, C dash. A dash, B dash, B dash, C and C dash. So which current is maximum at instant 3? Which phase current is maximum at instant 3? B phase current, sir. B phase current positive maximum, sir. Positive maximum means 10 ampere. We can observe here as dot and cross. So maximum flux will be contributed by this phase, and by the right hand curl rule, it can be observed that if the current flows in the direction of right hand thumb, then right hand curl is the direction of magnetic field. So sir, the direction of magnetic field can be represented here in this way. Most important part of the entire 3-phase induction machine, because if you are able to feel this, then only you are able to understand about the relative speed concepts. Hoping you are able to see the flux to be rotating. Now what is the position of north and south? Sir, the north will be here and south will be here. Are you able to see that the flux is rotating? Yes, sir. Yes, sir. Are you able to see the flux is rotating? Yes, sir. Instant 4 and 5 also. Let me show you 5 different instant. So 4 and 5, instant 4 and instant 5. I'm interested in 2 more instants. Please observe which phase current is going to be maximum at instant 4. Now this is your instant 4. Which phase current is going to be maximum at instant 4? At instant 4, sir, IA is negative maximum. IA negative maximum means positive maximum coming in, negative maximum going out. So this will be cross, this will be dot. So what is the direction of flux? Sir, it get reversed. Previously it is on this side. Now it is on this side. Hoping you are able to understand this properly. Yes, sir. Now this will be your north and this will be your south. If you want to represent magnetic line, then you can represent the magnetic lines in this way. Hoping you are able to understand this concept properly. Yes, sir. That portion of the material is said to be north, from where magnetic line of forces are coming out of the material, and that is said to be south, from where magnetic line of forces are going back to the material. Now again, last one, instant 5. Please observe instant 5. Which one is maximum at instant 5? Which one is maximum at instant 5? Which one is maximum at instant 5? At instant 5 we can observe, IC is maximum. So C phase positive maximum means 10 ampere. C phase positive maximum, sir. Positive maximum means this will be dot, this will be cross. Okay, sir. So magnetic line of forces are going to complete their path in this manner. As per the right hand curl rule, sir, if this will be, then it is going to complete its path in this manner. Is it okay? As per the right hand curl rule, we can mark the polarity. What is the position of north and south? This will be the position of north and south. Sir, we are able to see that the fluxes are changing its position onto the stator body. So the field is rotating, and we can see that the field is rotating in the direction as per the phase sequence of supply. First A phase is maximum, then after 120 degree B phase is maximum, after 120 degree C phase is maximum. So A phase is maximum, then B phase is maximum, then C phase is maximum. So the flux seems to be rotating as per the direction of phase sequence of supply. So sir, if we have a three-phase stator, please observe what I am saying. If we have three-phase stator, please observe what I am saying. If we have three-phase stator displaced in space by 120 degree, if we have three-phase stator, that is also called as balanced stator. If we have three-phase stator displaced in space by 120 degree, is supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field comes into the picture, which rotates onto the stator body, at synchronous speed. The speed of rotation depends upon the frequency of supply, and the direction of rotation depends upon the phase sequence of supply. If we are going to increase the frequency of supply, then the speed of rotation of field will be, sir, faster. Are you able to see this? Please tell me, have you seen the rotating fluxes onto the stator? Don't say that you are not able to see the rotating magnetic field. Now let's move to the little bit bookish language, so that we will able to identify what is the magnitude of the field. Okay, so when a three-phase stator displaced in space by 120 degree is supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced which rotates in space at synchronous speed, and the direction of rotation is same as phase sequence of supply, Hoping up to this part everything is clear. Hoping up to this part everything is clear. If you have any doubt, please feel free to ask. If you have any doubt, please feel free to ask. If you have any doubt, please feel free to ask. If you have any doubt, please feel free to ask. Okay. So let's move little bit in a bookish language. Write down. Write down. Think some part is missing. Please wait. Okay. Write down. Consider a three-phase stator. Consider a three-phase stator displaced in space by 120 degree. Consider a three-phase stator displaced in space by 120 degree. Consider three-phase stator displaced in space by 120 degree, as shown in figure A. Please, you need to draw this figure. Consider three-phase stator displaced in space by 120 degree. Now please see. Please observe, please observe. When A phase current flows, then what is the axis of AA dash? Please observe. When A phase current is maximum, what is the axis of AA dash? Sir, when A phase current is maximum, then we can represent the axis of AA dash, this one. This one is called as the magnetic axis of AA dash, because if the current flows in the direction of right hand thumb, then right hand curl is the direction of magnetic field. So this will be the field axis of AA dash. Is it okay? Yes, sir. So this is the axis of AA dash. Can I write in this way? Yes, sir. Then after 120 degree in time, current flows in BB dash. After 120 degree in time, current flows in BB dash. After 120 degree in time, current is maximum in BB dash. Then flux will be in the direction of, sir, flux will be in the direction of MMF axis of BB dash. So MMF axis of BB dash will be this. Can I represent in this way? 120 degree from AA dash is the axis of BB dash. Can I represent in this way? This is the axis of BB dash. Is it okay? Yes, sir. And after 120 degree in time, when the current flows in CC dash, after 120 degree in time, when the current flows in CC dash, these currents are not at the same time. The currents are being displaced in time by 120 degree. So first AA dash after 120 degree, BB dash after 120 degree, CC dash. When the current flows in CC dash to be maximum, as per the right hand curl rule, the magnetic line of forces are directed towards the axis of CC dash. So this will be the magnetic axis of CC dash. Is it okay? I can write axis of CC dash. Is it okay? So the flux at instant 1, flux is here. After 120 degree time, flux is here. After 120 degree time, flux is here. So the flux is changing its position. The flux is changing its position. Is it okay? Yes, sir. So I'm representing this to be axis of AA dash, axis of BB dash, axis of CC dash. Have you noted up to this part? Please tell me, have you noted up to this part? I am representing these axes here. A dash, 120 degree apart BB dash, 120 degree apart CC dash. Okay. So I am representing the axes again here. Okay, sir. Now write down. Assume every phase of a balanced three-phase system. Assume every phase of a balanced three-phase system is supplied by a balanced three-phase current displaced in time by 120 degree. Okay. So up to this part already you have noted. This part already you have noted in the last. Okay. Yes, sir. Up to this part you have noted. Consider a three-phase stator displaced in space by 120 degree, as shown in figure, is supplied by three-phase current displaced in time by 120 degree. Is it okay? Now write down. Current flowing in each phase produces their own fluxes. Current flowing in each phase produces their own fluxes. Suppose instantaneous fluxes are. So here I am representing phi 1. Please observe. Here I am representing phi 2 and here I am representing phi 3. Is it okay? Can I represent in this way? Yes, sir. Again, Current flowing into each phases produces their own fluxes on their own magnetic axes. Suppose the instantaneous fluxes are with respect to time. Suppose the fluxes are phi as phi m sine omega t. So the current flowing in B phase is after 120 degree in time. So that flux is displaced in time by 120 degree. And current flowing in C phase is 240 degree displaced. So that current is after further plus 120 degree, or you can say 240 degree. Is it okay? Yes, sir. So I am representing here. Instantaneous fluxes are phi 1 as phi m sine omega t, axis of A dash, that I am taking as a reference. So phi m sine omega t, phi 2 as phi m sine omega t plus 120 minus 120 degree, because this is going to be displaced in clockwise direction. Yes, sir. And this is displaced in anti-clockwise direction. So I am writing phi 3 as phi m sine omega t plus 120 degree. A balanced 3-phase winding displaced in space by 120 degree is supplied by a balanced 3-phase current displaced in time by 120 degree. So current flowing in each phases produces their own fluxes. And if I am assuming any one phase flux as an instant as a reference, so for phi 1 as a phi m sine omega t, in a time flux produced by B phase and C phase are being displaced in time by 120 degree. So I have represented in this way. Yes, sir. Now the difficulty is that these MMFs are there, but they are displaced in time, as well as they are displaced with their location also. Their physical position is also displaced by 120 degree. So in order to find the resultant flux in space, actual resultant flux, in order to find the actual resultant flux in space, we can resolve this along physical axes. So we have a physical axis, that is horizontal axis and vertical axis. So I'm going to resolve these component of fluxes along physical axes, that is horizontal and vertical axis. So this will be your phi 1, this will be your phi 2, this will be your phi 3, and this will be your horizontal axis, and this will be your vertical axis. So if this is 120, it can be clearly observed this one is 90, so this will be 30. If this is 30, this must be 60, sir, because 60 plus 30 is 90, so this must be 60, sir. Is it okay? Can I write in this way? Yes, sir. So because these fluxes are being displaced in time as well as their location is displaced in space, it is quite difficult to find the instantaneous flux in the air gap of the machine. For that, I am going to resolve along physical axes, that is horizontal and vertical axis. Okay? Yes, sir. Now please observe. So resolve the fluxes along physical axes. Resolve fluxes along physical axes. So first observe, please write down component of flux along horizontal axis. Component of flux along horizontal axis. Please observe, component of flux along horizontal axis. Please observe. So along horizontal axis, what you will get? Sir, phi 1 is there. If this is phi 2, then this will be your phi 2 cos 60. And same, this will be your phi 3 cos 60. Can I write in this way? Please tell me. Yes, sir. And since they are oppositely directed to horizontal, so you can say phi h is to be equals to phi 1 minus phi 2 cos 60 minus phi 3 cos 60. Yes, sir. So I am writing here phi h as phi 1 minus phi 2 cos 60 minus phi 3 cos 60. Is it okay? Yes, sir. Now we have the values of phi 1, phi 2 and phi 3. We can put the values. Phi 1 is phi m sin omega t, phi 2 is phi m sin omega t minus 120, and phi 3 is phi m sin omega t plus 120. On substituting the values of phi1, phi2 and phi3 and expanding, it means sin A plus B and sin A minus B if you are going to apply, and expanding, then after substituting the values, you will get horizontal component as 3 by 2 times of phi m sin omega t. And after substituting the values of phi1, phi2 and phi3, we get 3 by 2 phi m sin omega t. We get 3 by 2 phi m sin omega t. Now let's talk about the vertical component of fluxes. See, the derivation part is not so important because now we have an actual feeling. Let's talk about component of fluxes along vertical axis. So let's talk about component of fluxes along vertical axis. So vertical axis is this one. Yes, sir. Phi 1 cos 90, 0. Sir, this is 30. Again, we have a right angle triangle. If you observe, this will be a right angle triangle. And this is again a base component. So, sir, phi v is equals to phi 3 cos 60. Yes, sir. This will be phi 3 cos 60 and this will be phi 2 cos 30. Sorry. Phi 3 cos 30 and phi 2 cos 30. Is it okay? Yes, sir. So what is your vertical component? Vertical component will become, sir, phi 3 cos 30 minus of phi 2 cos 30 because they are oppositely directed. On substituting the values of phi 2 and phi 3 as phi m sin omega t minus 120 and phi m sin omega t plus 120, and after opening we will have 3 by 2 phi m cos omega t. So vertical component we have 3 by 2 phi m cos omega t. Horizontal component we have 3 by 2 phi m sin omega t. So we have two components, one is vertical and one is horizontal. Vertical component, have you noted up to this part? Now please observe, we have a vertical component and we have a horizontal component. So horizontal component we have 3 by 2 phi m cos omega t, and vertical component we have, sorry, sin omega t. 3 by 2 phi m sin omega t, and vertical component we have 3 by 2 phi m cos omega t. So can we find the resultant flux in the air gap of the machine? Yes, sir. So what is the resultant flux in the air gap of the machine? Sir, the resultant flux in the air gap of the machine can be represented by this one, that is phi resultant. So if you observe, the resultant is just below PW. So PW is going to make your result. Okay. So that joke apart. See. So we have resultant, sir. So what is phi resultant, sir? Phi resultant will become root over of horizontal component square plus vertical component square. What is horizontal component square, sir? Horizontal component square is 3 by 2 phi m sin omega t square plus of 3 by 2 phi m cos omega t square root over sin square omega t cos square omega t will become 1. 3 by 2 phi m square and root over will again become 3 by 2 phi m only. So the resultant flux is equals to 1.5 times of the maximum flux contributed by each phase. Phi m is the maximum flux contributed by one phase. So at any instant in the air gap of the machine, we are getting magnitude of the flux constant, and the magnitude of the flux is equals to 1.5 times of the maximum flux. Is it okay? Yes, sir. What about the position, sir? What about the position of the flux, sir? Let's talk about this theta. So what is the theta, sir? Tan theta will become phi v by phi h, vertical component by horizontal component. Everything will get cancelled out, cos omega t by sin omega t. That is cos omega t can be represented as sin omega t minus 90. So theta will become, sir, tan theta will become tan theta will become, this is cot theta. So cot theta can be represented as tan 90 minus theta. So theta will become pi by 2 minus omega t. It means, sir, the magnitude of the flux is constant. Magnitude of the flux is constant, but position of the flux is a time dependent. Position of the flux is a time dependent. Time dependent. Sir, magnitude of the flux is constant, but position of the flux is time dependent. Position of the flux is time dependent. So position of the flux is time dependent. However, your resultant flux is constant in magnitude. Resultant flux is constant in magnitude. Let's discuss about the position of the flux. So we are getting theta to be equals to pi by 2 minus 90. So let's talk about at omega t is equals to 0. Theta is equals to pi by 2 minus omega t. Pi by 2 minus omega t. Let's talk about omega t is equals to 0. So what is at omega t is equals to 0? Sir, the magnitude of the flux is 3 by 2 phi m and the position of the flux is 90 degree. So you can indicate the position of the flux here, sir. So this is the position of the flux 3 by 2 phi m and the position of the flux is A. A is the position of the flux 90 degree from the reference or horizontal axis. Okay. Yes, sir. At omega t is equals to 90. At omega t is equals to 90. Theta is equals to 0. Theta is equals to 0. It indicates the position of the flux is B. Magnitude of the flux is 3 by 2 phi m. Position of the flux is B. Please observe. Yes, sir. At omega t is equals to 180. At omega t is equals to, or at omega t is equals to 180. Omega t is 180, so this will become minus 90, sir, minus pi by 2. So from the reference, minus pi by 2 means the position of the flux is here. Magnitude is remain 3 by 2 phi m and this is your position C. Is it okay? Yes, sir. At omega t is equals to 270. Theta is equals to minus 180, sir. Minus 180 from the reference we can represent here. Yes, sir. Magnitude wise it is 3 by 2 phi m, sir. Magnitude wise it is 3 by 2 phi m. Position wise it is D. So we are able to see that the flux is rotating, sir. We are able to see that the flux is rotating, sir. Is it okay? And the rotation depends upon omega, and omega depends upon 2 pi f. F depends upon omega and f 2 pi f, and f depends upon frequency, depends upon p ns by 120. So synchronous speed of the revolving field will become 120 into f by p. Always remember, in this 120 into f by p, p is the number of poles, f is the frequency of current flowing into the winding. Yes, sir. We are able to see that. Sir, today we have physically, we have able to see the current, frequency of current. This is number of poles. Ns is speed of field. So synchronous speed of the field, the speed of the stator field itself called as a synchronous speed for this particular condition. So now we are able to understand, sir, when a three-phase stator displaced in space by 120 degrees supplied by three-phase current displaced in time by 120 degree, then a rotating magnetic field is produced of constant magnitude equals to 3 by 2 times of the maximum flux produced by each phase, and the direction of rotation depends upon the phase sequence. Also, the speed of rotation depends upon the frequency of current flowing into the winding. So hoping you have enjoyed today's lecture a lot. This lecture you should go at least once or twice revision with this topic, so that the rotating magnetic field will be in your brain. That concept is going to use every day in a 3-phase induction machine till we are learning about the 3-phase induction machine. Okay, so this concept is very important. You should be able to understand each and every part that I have tried to deliver in this lecture. Hoping you have enjoyed this lecture a lot. Thank you everyone. Love you all. Good night.